nodes. So the root will advertise a message that will contain information about the graph. Root or sink. Sometimes we called it gateway as well in IoT scenario. Root or sink nodes send ICMPv6. In internet, the messaging are sent to and from between nodes, and the protocol we use is ICMP, Internet Control Message Protocol. And ICMPv6 means Internet Control Message Protocol based on IPv6. So the root send the messages, and those messages are ICMPv6 messages. Okay, the root node send ICMPv6 messages. Those messages are known DIO, DODAG information object. So when the root node invite other node to join the network, so the messages that root node send to those nodes, these messages are called DIO, DODAG information object. And the node that receives that DIO messages will process these messages and make decision whether to join the graph or not, and also forward that DIO message to its own neighbors. And the neighbors then process that DIO messages and will decide that whether the node is going to join or not, and at the same time it will send that message to its own neighbor nodes. So this way the message from the root node will will go through all the nodes. Like this node send DIO messages. If this node is not going to join, it will send its neighbors DIO messages, and it will send to its own neighbors DIO messages. If they want to join, then they will send another message that message types is different than DIO. So this process continues such that the DAG topology is built from the sink node towards the edge nodes. So these are the edge nodes. These are edge nodes. Okay. Edge nodes means there is no further any node, or this is the boundary, you can say, boundary of a network. So node that join the graph acts in one of the two ways. So the nodes that join the graph will become either router or either become a leaf node. So if we node, they might come the router or become the leaf node. Leaf node is the same as the edge node. Leaf node, if this node becomes a leaf node, it will not send DIO messages to its neighbors, and obviously it cannot send. So it will not send DIO message to its neighbors because it's a leaf node. If it is a router, then the router has that additional service to send the DIO messages of a root node. So leaf node doesn't send the DIO messages. All the neighboring pairs repeat this whole process and build the graph. All the leaf nodes send data packets hop by hop towards root and represents a multi-point to point model. Leaf nodes have redundant paths toward the sink node. Means the root node, the leaf node may have multiple paths to reach to destination. Okay. So So this is a graph building process. You can see this is our sync node, and it is advertising network information to its neighbors. And the next stage, what neighbors does, the neighbors send the same information to other neighbors. And then finally it comes to the leaf node, and we have that sort of network. So the way DIU messages travels, the packet, if this node want to send the packet, it will follow the same path from where it was initially built. This is one of the routing topology. In this topology, how many messages, what types of messages are here? There are three types of messages: DIO, DAO, and DIS. DIO messages, who can send, who can use this message? It is a root node, or you can say sync node, or you can say border router. DODAG, destination advertisement object, and DODAG, information solicitation messages. So there are three types of messages. We are going to explore this individually. I have already told you what are the DIO messages, so I'm going to skip this. So DIO messages are sent by the router in upward direction along the DAG to enable the point to multi-point traffic in downward direction. Okay, so we have root, and there is, and there is, and this is one of the router. So the router send information to this, and the message type is DAO. So the router send the message in upward direction, this way, and will get the traffic from the sync to this from the same path in downward direction. And these messages can be multicast, that are sent from a child node to selected. Yeah, if it has another path to this, it may be use a multicast, means this router can send the same message DO from two different ways, like this one, this way, or in this way, multicast or broadcast. Okay, nodes. So what sort of information it will send to root? What is in DO message? For example, there is another node. There is a node. And that node is not yet part of the network. It will then broadcast a message. And if this router received that message, so it will read that this node want to join that network. So it will send that message to sync via different routes. And then this route will decide that whether we should ask this node to join or not. So the message that router sent to root about joining of this is known as DAO. Nodes inform parents of their presence. And another purpose of DAO is that this one shows. Let me grab another pen. So okay, another purpose of DAO is that it is a sort of like attendance, or it is a sort of a way to inform the root that I am here, I am present, I'm not like disconnected. DO messages include the RPL instance ID. So what would be in DAO? DAO messages consist of RPL instance ID, DAO rank. For example, it has a rank 3. DAO lifetime, sorry, route tags and destination prefix. So these are the information that consists in a DAO message. And the third type of message is DIS message. This is our root. Do you know which message is used to join the network? That message is known as DIO. And that router, not router, the root node or sync node or a gateway or a border router send this message DIO and ask the node to join them. So if we have another node and that node want to join, it will send a message that I want to join. That message is called DIS. When the DIS message received here, then it will get a DIO message. So you can say to trigger DIO, this node needs to send DIS message. So DIS message trigger DIO message. And here you can see an example. So this is old, means you can say it is a sync router, not router, root node. It is a sync, and that is a new node. So the node will send DIS message, and then this old or sync will send DIO message. This will send DAO message. DAO means this will give its information that what is what necessary information it has to join the network, and then the sync acknowledge the DAO, and then it becomes part of the network. So this is how it building the graph. And the base of the rank, you see, base of the rank, data can be sent. If this one want to send the data, it will send it to, look, it has only one path. It will send here, and then there, and then here. And for example, let's suppose there are two paths. One, from there the message can send to A, or let's suppose this one has two paths. One is from here and one is from here. And the rank of this is 2 and the rank of this is 4. So based on the lowest rank, it will prefer this node to send the message. And this way the message forwarded from source to destination. All right, so okay, another one you can say the advantage is that some nodes are root node, Some are known as stateless node and some are stateful node. So these are stateless node. Means they cannot generate DIO messages, and even they cannot they cannot accumulate information from other nodes. Only the I node, this one, stateful nodes, will collect the data. For example, it sends this message of joining. The F will send it to I, and then H want to join, and it send information to F. F will send it to I. So I will collect information of G and H, and it might collect information from K as well. So the I is a collection point of the messages, and then send all the messages at once to 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 the destination, to root node. This is just an example. We have here a graph, and this node want to join. If this node want to join, then it will send information that is known as DIS. Then the group leader, for example, this one, will send DIO, and this will send then its own information to this leader. What about DAO? And that will be then acknowledged, and it will become part of this group. Let me see, I have some WhatsApp messages. Oh, some people are saying they are unable to join. I don't know, there would be a problem of internet connectivity or what. So, all right. We now is the time to see that how the DODAG network is formed in Contiki operating system. Okay, where is the Contiki operating system? Can you see my screen? And what is it on my screen?
Yes, sir.
Screen show हो रही है सर.
Can you see my screen now?
Yes, sir.
What is it?
Sir, maybe
Start हो गया और जब विंडो में हमने लॉगिन कर लिया सर.
Okay, okay. Okay, here we have a Kuja simulator, Contiki running under Contiki operating system. Okay, so sorry, my mic was mute.
Yes, sir.
Okay, so I didn't know that my mic is mute. Okay, so you have added 12 nodes, 12 modes. Okay, and let's group that. go to zoom out, and we want a radio environment. We want to grid it. We also want to see radio traffic, and yeah, that's all right. More type. So let's move it here. And group them here. So you can see number 4 is away from number 3. And number 3 is away from number 4 and 5. So you can see there are 2 groups of nodes. And there are 2 clusters. Let's make it like this way. All right, so now I think pretty much we are there. And now add 2 more modes, but this time we are going to get sync, 2 sync node, 2 sync. Okay, so where are the sync node? 13, put it here, 14, and put it here. So there are 2 clusters, and the cluster and the 13 is the sync node. We just got a presentation where I told you that we have some nodes and there is a sync or root node. So this is our root node, and this is the root node of another network. You can see 13 is pretty much covering 8, 2, 7, 10, and 3. And they will send all messages to 13. And we want to get a view of 13 and 14. Make it here. This is 13. We have a collect view. So we have view of 13 cluster. This is a view. We want to see that what is coming in and out. So this is for 13. You can see when I click that, you will see the blinking of the node. This shows that this is linked with this. So from here, if you see clearly, the mode view, it is not sending any byte and not sending and receiving any byte. So the status is 00 byte. 14, the same, similarly, 14 is not sending any, sending byte are 0 and receiving byte is 0. And here, if I, sorry, and here, what is it? Oh, yeah, okay. Here you can see, this is 13 and 14. Okay, so here you can see one of the view, collect view of either it is a 13 or 14, but this is a view from where you can see different statistics. For example, you can see the network, sensors, and power. Power means it will show that how much each node is using power for sending data or receiving the data or processing the data. And we have network graph. Yeah, it is for 14 because there's a node of 14, and we can see the 12 as well, 7 as well, 8 as well, and this means it is this cluster. Okay, and this is beacon interval. ATX is a matrix of a path. Like a path will have an matrix ETX. Every path has some, for example, 7 sends the data to 14 and 14 to 3 and 3, 4 and 4 is ended at 13. So every path has ATX value. So based on the ATX value, it will select the best path. ETX means expected transmission time. So there are some more you can see. We will examine, and you can see here. These are the nodes. Just forget the decimal points. So you can see 6, 7, 8, 10, 11, 12, and 14, and these are all our nodes. No, I think 3 is missing here. But we will get that. We will get the latest updated one once I started the simulation. So I'm going to start the simulation and then examine the network graph. Examine the network graph. At the moment, you can see there is no link. So they are not connected to each other yet because the power is not turned on. So I'm going to start that. I have started it. And you can see there is some initial building graph. Everyone is sending request, and some requests are DIS, DIO, and then after sometimes it will be settled down, and we can then see. And you can see here 14. This shows that 544 bytes has been sent. So let's collect that, send command, start collection. So when I set that start collection, you can see that here the bytes are sending and we are receiving something. Let's do here as well. So if I click start, we can see bytes are sending, and there are some bytes that we are going to receive as well. Sensor map, you can see 10 is sending data to 14 on the graph. And here now 8 has sent data, and all the nodes are now communicating with this 3 and 14. 3 and 6 has not yet sent any data because 6 is not part of this. I think, yeah, 6 is not part of this. 6 is part of the other cluster. Let's check here. And if you go to par, you can see that this is the left cluster. We can see there is the 5 node, the number 5 node. There are some colors. So one color is the blue means CPU processing, how much it takes processing. So power is in milliwatt. And another is radio listening. The green one, it shows that the node 5 is using power 0.5 milliwatt to 0.9 milliwatt just for listening, and the radio transmitter is using that much power. At any instance, these are the power. Like 11 has, the node 4 hasn't the yellow part. Now it got a yellow part. It means it has received something. And the 11 hasn't yellow part. This means that 11 is not receiving yet. It's not using power to receive. Now 11 has got some data, and they use some power to receive. Okay, so this is a simulation, and you can add your nodes, and you can get some values, you can also envisage some characteristics of your network. You can build a virtual IoT network and then analyze it, that at how many time it takes to converge. Even you can some assign some temperature as well, some sensor as well. Where's sensor? Node information. All right. This is the node information that you have seen in the graph. This is a tabulated format. You just copy that and put it in an Excel sheet. For example, CPU power, LPM power. Like node 2 has LPM power of this, listening power of this, transmitting power of this. These are the tabulated values. But if you want to see in type of, or in sort of, or in terms of graph, you can see here. Okay, so now you have this graph, and if I take this out, now the 10 is out of the cluster. So 10 is away from the 14, and let's see in the graph that where is 10, whether 10 is doing some communication. Here, 10 is here. Give it a time to update. Start collect. And now see. Start collect. And let's read some messages here. This is an IPv6 address. Let's see. All right, so let's move down. So today we have discussed DODAG, and we have gone through with a simulation where we have two networks and how these networks joined. After some time it's stable and then start communicating, and these are the messages. Let me reload that again. Radio traffic, radio messages. And this shows that this shows that messages are going from this node to, this means 5 hasn't yet start sending messages yet. And if you click to any data type like this one, you will have some additional information about headers. Okay, next time we will, what we're gonna see, next time, let me stop it. So next time, how to stop, yeah. Next time we will attach sensors to those nodes, modes. So, okay, modes. Let me show you what is the modes. Okay, physically modes looks like this. Or you can use Arduino as well. For example, this is an Arduino and we attach some sensors to this, and the sensors will sense something and send it to Arduino. Then Arduino has a wireless module that could be Bluetooth or Wi-Fi or anything, and this will send wirelessly to 14. So they are using mode. So the mode is that sort of module. The mode consists of the board, sensors, and communication technology like Wi-Fi, Bluetooth, Zigbee, or etc. So we will add some sensor to this. In our case, like in my office, I have Arduino and we attach sensors to this, and I attach Zigbee or Wi-Fi modules, and it will wirelessly transfer data to my laptop. So in that scenario, my laptop is number 14 and the 8 is my Arduino and there is a sensor attached to it. So we will see that how we can attach a sensor to 8 and then we will wirelessly access the sensor data, how it looks like, how to add sensors and remove the sensors. So we'll go through all these things in some other lectures. Okay, so for this lectures, we are up now. If you have any questions, then you may ask. Your exam paper, I don't know, is it going on 29th or after 29th November? The paper will consist of objective type and subjective type questions. There will be 10 marks of objective multi-choice question MCQs, and there would be a second question that consists of 2 short questions. And at the end, the third question will have a single question. You will have to briefly describe. That would be like, for example, that question would be, what is wireless sensor network? Or what is RPL topology? Okay, one more thing. Today's lecture is not included in your paper. This is part of final. So whatever we have delivered, a part of today's will be the part of your exam, your midterm exam. So
Okay, sir.
all questions carries equal marks. Question number 1 would be 10 marks, and 2 would be of 10 marks, and 3 would be 10 marks. I will leave space in question paper. You can write your answer there. So any doubt?
No, sir.
Okay then. Good luck. Bye.
Thank you, sir.
And Hafeez, sir.